one of the four fundamental forces is gravity. And there are other three. We will deal with gravity and electromagnetic in this course and leave the other two, weak nuclear, strong nuclear, for later physics if you want. Now, but if you talk about force types, gravity is one stands alone. And there are some other forces like spring forces, Hooke's law, and tension forces, normal forces, friction forces. We all will touch a little bit. Now, for this lab, we focus on the gravity. Gravity is that of a universal attraction between any two objects. They attract. A attract B, B attract A. So Newton find out this. The formula he proposed is this. The force, the magnitude, is proportional to the mass, m1 and m2, no doubt, is the object. And then the strength is inversely proportional to the distance between two objects squared. And it is very weak, so normally you wouldn't detect the gravity force, say, between a table and a chair, because this constant in front of this formula is so tiny, it's so small that it's negligible. But if one of these objects is huge, like the Earth or the Sun, or your chair and the Earth, so then the distance is large, then this force becomes significant, at least noticeable. So in this class, next week or this week, we will study the gravity is one of the forces. So when they go far away, you will have a weaker force. When it's close, it will stronger force. In this week's lab, you download from Moodle this lab folder and you unzip it, and inside you will find several files. And this satellite is a standalone program that will simulate gravity and planets and gravity. Basically the Earth and the object on Earth. And then you will start from here. Okay, you will start from here, and then you will see this situation if you have a Earth, like a planet, and if there's another meteor go pass through, and then its orbit will change, because if you go this way, and then it will affected by gravity, so its trajectory will change, even though it escapes. And there is another situation if its kinetic energy, if it's slow enough, and its gravity, it will fall into the Earth. And there is such a sweet spot in some intermediate speed, and when the gravity goes, and then they will go into the orbit. And so this lab, we will play with the software, and we cut in the satellite and play with this and see what we can do. Now, if you open the folder, okay, you have four. You don't have to touch all this. This is actually a program, actually made in C++ for those of you who are in computer science majors. And then if you double click this one, it will start these. You don't have to ignore these numbers, but this is nothing but as simulations, continuously calculating the gravity based on those formulas, believe it or not. So we have the Earth. So if you just play with that and see, hold on, you can grab the balls and then move around and see if you go far away, the gravity is weak. Look at the green ball. Let it go, it's slowly moving toward the Earth. Alright, but if you hold this, and from here the gravity is stronger. Recall Newton's second law. If the same mass, if the force is stronger, it will have a faster acceleration. And if we go here, if we look at the green ball, if I let go, it's even larger situation. So it goes with inverse distance squared. So, but it's very, very, very far, so the gravity is very weak, but it's all towards the things. And then now if I grab this one and go to the other side, wherever it goes, it will toward the center. So now the challenge here is, first of all, the challenge here is to play with it. Of course, you get familiar with it, so you can grab and you can throw the ball at whatever speed you want, at whichever direction, and when you throw, you have to release the button. Once you get used to it, and just like you grab things and pick up a stone, and when you throw and let it go, and it will go. Okay, and so now you have the challenge here is to try to get at least one of the balls circling the Earth. Okay, previously student could get 2 or more, even 3 of them orbiting, and you can receive extra credit for that. But at least you should do 1. Okay, when you are successful, take a video. Maybe that video only lasts like 20 seconds or so, and insert a link to your video into this document. Don't send the video file, but try to learn how to upload that into your Instagram or YouTube, but put a link in a Word file. So that's a good skill. Okay, I will ask you to do this very often. Take a video, but don't send the video file. Just put some online somewhere and send the link. So, and that's first challenge. That's first part. And then after that is done, you just answer some questions. Okay, now I give you some hint of this, just to see if you have watched this video. Gravitational attraction force is proportional to the mass of the two objects, product of the two masses. Okay, and gravitational attraction force is inversely proportional to the between two objects. Excuse me, I have a spelling error. The distance. All right, the farther away from the center, the Earth, the stronger or the weaker the gravitational attraction force. Okay, what is the value of gravitational constant G? About that I will not tell you, but you can find out and put it in the correct units, and it will be all you have to remember is a very small number. You see in that formula, and this G is multiplied with the product and the inverse square of the distance, and so the normal two object will not have any significant gravity. So only when one of the mass is huge, then we will see the effect of gravity. So that's this one. And the last question, I will talk a little more about this. That's if you describe the object around Earth actually follow a orbit. Okay, that orbit, if you draw the x and y direction, and both x and y direction are changing with time, so that you have a trajectory. So then, if this is actually their formula, this is called parametrized equations. Okay, if you calculate this, just using your calculator and set the angle to be using radians instead of degrees, and calculate this thing. 1 day, right? 0, 10% of the day, and 20% of the day, and so on, and divide it on day by 10, the whole day, and then calculate, just honestly, just press the calculator and get the number here, and then put all these orbits, dots, each of these x, y pairs, put the dots here, and see what the orbit look like. That's how mathematically they describe the trajectory of any interplanet orbit or some planet orbit around a center. Now let me give a try on this. So try to make different orbits. So then this, catch it. So well, the other two are already gone. You try to push it. This I slow and faster. So okay, this is funny, right? So now this way, well, this is a situation that you learn that a moon, like something, is nothing but something is thrown very fast, but it will not land on the Earth. But this one, catch it. I'll catch this one. Well, if this happens, but you have to restart. Okay, let me try again. See if I don't want this video to be too long. Okay, so get all three of them circling. Let me try to get one of them. Just don't lose hope. I'm telling you, this can be done. Okay, that's in orbit, but it go out of scope. That's no fun. Let me go slower. Okay, see that yellow one? It's not in the right direction. Watch. So this white one. Okay, so that one, that's too fast. Alright, so this white one now is into orbit now. So, you see, its attraction, why it will not fall onto Earth? Because it's going very fast. It doesn't mean that Earth has no effect on it, because Earth is constantly accelerating it towards the center, but it's going towards the center, but it tries to land, but there's nowhere to touch. So that's actually, you can say this object is constantly falling, but there's no thing to touch. But okay, that one came back. Yeah, the larger orbit was slower, but close orbit, near Earth orbit is faster. That's true for all the satellite and planets and so on. Alright, try to get all three circulating, you will get extra credit. But at least you should get one circulation, take a video, and submit the video. Alright. So the last question, one more time. You can go by hand, cosine and sine in radians, and put this and find out x and y. There are two formulas, and put this on here. So the first dot, for example, is 0, 1, and then see what the orbit actually look like. So it's a parameterized equation. Or you want to be more advanced, tired of using calculator, you can use the Excel. So that you can use, but don't use this one. But this is good enough. See, you have this x, and so this is the original data. You have x and y. You just type in and click here. See that formula is right here. Cosine 2 pi. So that one is A2. A2. So this one is A2. So then this one is simply you hold this corner and pull down, and it will apply this formula across the board, and same formula. So this one, B2 is A3, B3 is everything is the same, A4, and so on. I calculate all that. Okay, if you use your calculator to check the data, see if you get exactly the same. And you do the same thing for y, except you will sign of this. And you can do by hand, but if you're too much, you can just do this. And once you have this column data, for example, you can delete this. How do you generate this? You select these two. Okay, so you select this data and hold Shift. Only when you hold Shift, you can select this again. Okay, once you have that, and then you insert scatter plot. Where is that? Scatter plot. Boom. See here. See the first dot. Yeah, this is 1, 0. So 1, 0 is this one, and so on. The second one is go one whole day and 10 step. 1, 0.1, 0.2, 0.3, and then so on. 10% of the day is roughly 2 hours. So, but don't pay too much attention about the shape, because that's because of the scale. So if you put it too longer, it will become a circle. But only when you have exactly the same scale, you see the square, and you will know what kind of a orbit is it. So you see, if you have a square grid, you will see this orbit is actually a square. But then in our real case, so I have a factor of 2 here. Okay, and a factor of 2 here. If I put a factor of 2, then you will see 2. So I put a 2 in front. 2 times that. Then it will be a 2 times that. So not 22. So then one side will be stretched longer. The horizontal direction tries to stretch longer. Then you will see, if I plot this again and stretch the whole thing. So it goes like this. It's different. So you can play with that, and but basically you exactly put into these 2 pi a n times 2 and 2 pi a x sine times 2. So you have this orbit. Well, hope this helps. If you have a question, just let me know. Bye bye for now. So this is the end of lab for there. So we talked about this last question.